Hey, what's up everybody? My name is Moz, and in this video, I'm going to show you how to quickly set up monitoring and alerting for your Kubernetes clusters using Splunk Observability Cloud. We'll walk through deploying the OpenTelemetry Collector, setting up a sample application, and then intentionally triggering an issue to see Splunk's AutoDetect alerts in action. So before I jump into the demo, I want to answer the question, why Kubernetes? Kubernetes has become the backbone of modern cloud applications, and it's designed to handle workloads at any scale. Here are some of the benefits of Kubernetes, or KATES for short. One of its major strengths is scalability because Kubernetes automatically adjusts resources based on demand, ensuring that applications stay performant without over-provisioning. It also enables microservices architectures where different services can run independently using the best-suited technologies for each task. Another advantage is automation. Whether it's rolling out updates, handling rollbacks, or restarting failed containers, Kubernetes minimizes manual intervention. But Kubernetes and microservices can be challenging to work with. Larger environments with hundreds or even thousands of microservices can make resource management difficult. With frequent deployments, ensuring smooth rollouts without breaking dependencies is critical. Knowing how microservices interact is another challenge, especially as infrastructure constantly changes. And because containers are ephemeral, they're short-lived, spinning up and down automatically, traditional monitoring tools often struggle to provide real-time visibility. And this is where Splunk Observability Cloud comes in. It easily integrates with OpenTelemetry, which is the industry standard for collecting and analyzing telemetry data. And Splunk Observability Cloud provides a guided setup to deploy the OpenTelemetry Collector to your Kubernetes cluster with a single Helm command. Once the collector is deployed to your cluster, you can visit the Kubernetes Navigator in Splunk Observability Cloud, which provides a real-time view of your cluster health. And finally, through AutoDetect detectors and alerts, Splunk Observability Cloud provides automated detection and alerting, helping you identify and respond to issues before they impact users. With these tools, teams can confidently monitor, troubleshoot, and optimize Kubernetes environments at scale. Now let's see it in action. Okay, so the first thing that I want to do is quickly show you the Kubernetes environment that I want to monitor. It's a single node environment that I'm currently connected to over SSH, and we can use K9s to take a look at that cluster. I'll navigate into the default namespace, and you can see that there's currently nothing deployed in the default namespace. I'll go back up to the namespace level, and if we take a look at all, you can see that there's nothing here related to OpenTelemetry yet. So I'll go ahead and quit K9s. Now I'm going to navigate to Splunk Observability Cloud. And from the home page, I'm going to navigate to Data Management. And I'm going to select Add Integration. And I'll search for Kubernetes. This guided setup will allow me to deploy the OpenTelemetry Collector to my Kubernetes cluster using a Helm chart. I'll select Next. We'll keep the platform as the same, and I'm going to leave Gateway as No. I'll call it Lab Environment, and then I'll provide a name for the cluster. The provider dropdown allows me to specify the cloud provider that the OTel collector is going to be deployed on. And the reason you would want to specify the cloud provider is because the collector will then add additional dimensions to the data that it's sending to Splunk Observability Cloud that is provider specific. So for instance, if you're running the collector in AWS EC2, then the collector will push relevant metadata like the instance type and the availability zone to Splunk Observability Cloud. In my case, I'm running it on a virtual machine, so I'm just going to select Other. The distribution dropdown allows you to select which distribution of Kubernetes the OTel collector is going to be deployed on. And again, similar to the provider selection, this is going to add additional metadata specific to the distribution that you select. In my case, I'm running a K3s cluster on my VM, which is not available in this dropdown, so I'm going to select Other. I'll leave the log collection as is, and then I'll also leave auto discovery enabled. I am going to deselect the zero code instrumentation here for these languages. In this demo, we're going to be utilizing a Python application for our example. I'll leave profiling set to true, and then for the Splunk access token, I'm going to select an ingest token that I previously created. And then I'll select next. And what the guided setup does is it compiles the commands for you that you would need to run on your Kubernetes cluster in order to deploy the OpenTelemetry Collector. And for clarification, we are deploying the Splunk distribution of the OpenTelemetry Collector. So the first step here is to add the Helm chart repository. So I'm going to copy this command, and I'll navigate back to my node. I'll paste the command in and hit enter. In my case, I had already added the repository, but you should see a confirmation message saying that the repository has been added. Next, we'll perform a Helm repo update. And then we should be able to deploy the Helm chart with this Helm install command here. And what you'll notice as we look over the options that are being passed into this command is that all of the selections that we made on the previous screens are included as arguments to the command here. So I'll copy this command to the clipboard and then navigate back to my node. And I'm going to paste it in and hit enter. And it looks like it was deployed successfully, so let's take a look at K9s. As you can see in the default namespace, it looks like both the Splunk OTel Collector agent and the cluster receiver have been deployed successfully. Let's take a look back at the guided setup page. I'll select next. And as you can see, data has already started streaming in from the OTel collector. I can see the node names in my cluster, the namespaces, as well as the pod counts. Let's navigate back to the home page. And from here, I'm going to navigate to infrastructure. And under the containers section, I'm going to select Kubernetes. I'll select Kubernetes clusters. This is the Kubernetes Navigator in Splunk Observability Cloud. And this clusters page provides a high-level overview of the clusters that I've connected to this organization in Splunk Observability Cloud. I'm going to navigate into my cluster. From the cluster page, I can review high-level data about my cluster. But in addition to these high-level metrics for the cluster, we can also view various entities in the cluster. So for instance, I could look at Kubernetes nodes. And if I select this button, I can see a heat map of all of the nodes across all of my clusters. It's worth taking a look at the node dependencies window over here. You'll notice that there are two services, MySQL and Redis, identified as running in one of the clusters, not my cluster, but one of the clusters that are deployed. And this discovery happens automatically. If you've deployed a third-party application such as MySQL to a cluster and you deploy the Splunk distribution of the OTel collector with auto discovery enabled, it will recognize these third-party applications running, and you'll be able to see these applications in the node dependencies window here. And selecting one of these services takes you to a dashboard with metrics that are specific to that service. Now what I'll do here with the heat map is group by Kubernetes cluster. You'll notice as I hover over each one of these selections, it will dynamically update the page to represent that grouping. And then I can select my cluster to see metrics specific to my cluster nodes. And in my case, I only have a single node deployed in this cluster. But from this page, you're able to see various metrics related to the nodes in my cluster. And if I select this node, it will take me to a more detailed view of the workloads that are running on this particular node. So I'll expand this hierarchy map. And in the hierarchy map, we can view specific pods and containers within those pods on this particular node. These tabs down here allow me to view metrics specific to each Kubernetes entity. So right now we're looking at node metrics, but then if I selected Kate's pods, we would be able to see metrics related to the pods running on this node. I'm not currently pushing the node logs, but another feature here is the Kate's Analyzer. This is a useful feature that automatically identifies potential patterns in problems. So if there are matching attributes across multiple pods that are consistently restarting, you will see those pods and attributes show up in the list here. Okay, so now that we're familiar with the Kubernetes Navigator, I'm going to deploy a simple Python server to that Kubernetes cluster. I'll navigate back to VS Code. Let's take a look at this Python server deployment.yaml. This is a very simple deployment that runs one replica with the Python image, and it's running the simple HTTP Python server. I'm going to run kubectl apply. And then let's take a look at that deployment in K9s real quick. And as you can see, it looks like it's been deployed successfully. So let's navigate back to Splunk Observability Cloud. And what you'll notice in the node hierarchy map is the pod has already appeared for that Python server in the container that it's running in. If we click into that pod, we should be able to get pod-specific metrics. I'll navigate back up to the node level. And what I want to demonstrate is Splunk's AutoDetect detectors and alerts. AutoDetect detectors are something that you don't have to configure yourself. They're available automatically when you connect your Kubernetes cluster to Splunk Observability Cloud. And there are a specific set of detectors dedicated to Kubernetes environments. If we open up the detectors and SLOs page in a new tab, we'll be able to see specifically what detectors are available for Kate's. I'll select the detectors tab. And then from the all detectors dropdown, I'm going to deselect standard and customized. And then I'll search for Kate's. And here we can see all of the Kate's related AutoDetect detectors, which are identified by this symbol here. The one that I'm going to try and trigger is this first one here. Kate's container restarted count is greater than 0. We can see that it's actually been triggered 5 times before. And if I click on it, I can see a detailed view of the alert. So this detector is pretty simple. It just alerts you when the container restart count is greater than 0 in the last 5 minutes. And down here, if you want to be notified of the alert outside of the tool, you can add recipients, and there's multiple methods that you can use to send alerts. Right now, this detector is monitoring data across all of the Kubernetes clusters. But if I wanted this AutoDetect detector to only monitor data from my cluster, I would need to add a filter. You'll notice that the Add Filters button is grayed out. And that's because in order to add a filter, I need to create a customized version of this detector and then filter on my specific cluster. So let's see if we can trigger that alert by modifying the deployment of the Python application. What I'm going to do is navigate back to VS Code, and I'm going to exit K9s, and then I'll modify that deployment file. And we're going to force the deployment to crash. So I'm invoking Python in this command, importing the system library, and then making a call to exit the program with an exit code of 1, which is a failure. And I'm going to reapply that deployment. Before we navigate back to Splunk Observability Cloud, I'm going to pull up K9s just so that we can confirm that this deployment is crashing. And as you can see here, it appears that the pod is in a crash loop backoff state, and it's exiting with an error, as expected. Let's take a look at Splunk Observability Cloud. In about 5 minutes, we should see the alert count increment for this Kate's container restarted count detector. And let's take a look at the node hierarchy map as well. In the node hierarchy map, you can also see the failed containers within the Python pod. I'll navigate back to the detector, and I'll open up this detector. When we look at the detector timeline, you can see here is my Python server and the increasing number of container restarts. Once we've reached a duration of 5 minutes, we should see a red triangle show up at the bottom of the timeline. And it took a little while for this alert to render, but if I select it, you can see in the description here that this is for the Python server and that it's currently ongoing. I'll exit out of this detector view and I'm going to navigate directly to the alert. In the alert page, it gives me more specific data filtered down to my deployment. And we can see down here that the signal value for container restarts was 4, and the triggering condition was that the value of the container restarted is above 0. And from the alert page, under the Explore Further section, I can navigate directly to APM or infrastructure monitoring to further troubleshoot the issue. And if I navigate to one of these services from this link, the page will be automatically filtered for my specific cluster and my specific deployment. And remember that I didn't have to do anything to configure this detector. It was automatically available when I connected my Kubernetes cluster to Splunk Observability Cloud. Now I'm going to resolve this issue by modifying the Python deployment again. So I'll navigate to VS Code, and I'll exit K9s. And I'll open up the Python deployment, and we're going to remove this line here. So I'm going to replace that command with running the Python HTTP server again. And let's redeploy that deployment. I'm going to open up K9s just to confirm that it's running. And it looks like the deployment is running successfully, so let's navigate back to Splunk Observability Cloud. I'm going to scroll down here and I'll select Resolve Alert. And then I'm going to navigate back to the node hierarchy map and just confirm that the pod is showing that it's running successfully. And you can see that the pod color changed from orange to green, indicating that it is currently running and the pod phase is known. Let's quickly recap the steps that we took. First, we used the guided setup in Splunk Observability Cloud to deploy the Splunk distribution of the OTel collector to our Kubernetes cluster. Once the OTel collector was pushing data, we then deployed a simple Python server to our Kubernetes cluster and observed the deployments in Splunk Observability Cloud's Kubernetes Navigator. I then modified the deployment to purposefully create a crash loop backoff state. When that occurred, the AutoDetect detectors that monitor container restarts alerted. We were then able to review and resolve the alert accordingly, and we didn't have to do any configuration for the AutoDetect detectors to alert. This demonstration shows how quickly you can set up effective monitoring for your Kubernetes cluster using Splunk Observability Cloud and the Splunk distribution of the OpenTelemetry Collector. I hope you enjoyed this video, and if you did, we'd love to hear your feedback. And if you're interested in trying Splunk Observability Cloud yourself, You can navigate to this link to claim your free 14-day trial. Thanks for watching.